What's up? What's up? It's your man, Jimmy Chan. All right, so today we're talking about exponential functions. All right, exponential function has a form of f of x is equal to some kind of constant times a raised to the x. Okay, so the a is typically a number as well. Sometimes it will be an e, but most likely it's gonna be a number. All right, so it's gonna look something like this. So here are some properties, right? The domain is gonna go from negative infinity to positive infinity because it's gonna look like this shape here. The range is gonna go from 0 to positive infinity because there's gonna be no negative y values. Everything is gonna be positive, all right? So what else is there is the fact that it's always gonna cross 0, 1. That's number one. Number two, when you raise any a value, right? Because again, let me take a look at it this way here, because I said it was a to the x. Okay, so if I take a and raise it to 0 power, anything raised to the 0 power is 1. So that's why this is 1, and this x value is 0. Okay, so and then over here, well, a raised to the first power is going to equal to a. So again, my x value, so this is my y value. So that's why I have that. All right. So now my next question is, what if I had a raised to the negative 1 power? Well, what does that do? Well, that will flip the fraction, right? It doesn't like being on top, so it's now going to be moved to the bottom. That's why we have that. Okay. So, and you're like, whoa, that was back in the day. You're right. Those were from back in the day. Those were called the exponent rules, right? Remember these? Where if we multiply the same base with different powers, we add the powers. If we raise a power to a power, we multiply the powers. And here, it feels like we're distributing powers, right? And then if it's raised to a negative power, then we move it. If it doesn't like being on top, it goes to the bottom. If it didn't like being on the bottom, then it would move to the top, right? And then this constant is sometimes going to be there. Majority of the time it's going to be a 1, but sometimes it's going to be there. So you got to kind of respect it. All right. Now, what if this c was a negative, right? What if the c was a negative? Right now the c is a positive. That's why it's going this way. What if it's a negative? Well, if this was a negative, what does it affect, right? So that's where we kind of have to look at things as we go, all right? And of course, the a is going to be important as well, all right? But we'll get into it as we get into further. Now, this a value right here can actually be predicted. If you were given a graph and you can find what the y value is at x, whatever value you pick, but the next x value, you find that y value, and the quotient of that would be the value of a. All right. So, but this is all the information that you need to know at this point in time. Let's get into some examples. So, let's say I had to, or the problem is asking you to evaluate. So let's say it's asking you to evaluate 8 to the 2/3 power. Okay, so a couple of things we need to be able to do. One of the things I talked about with this is that, we have the sun shining and we have the grass growing. Right? Of course, every tree has a hole in the middle for the squirrels to go into. So here is where we kind of talk about this part, right? So the grass is what divides the ground and the sun. The sun, which is above the ground, gives us power. Below the ground, we don't get any sun, but it gives us roots, right? So this right here is a fraction that is kind of important to us as we look at these exponent rules that we're dealing with right now. So let me try to make a square there, okay? So notice that the grass is now my so-called fraction, okay? So now if I look at this, if you look at that, this is the same as saying 8 to the, those are my fraction, right? The 2 is my power, because it's above the grass, and below the grass is the roots. So I break this down, this is going to be 8 excuse me. This is going to be the cube root of 8 squared or it's going to be the cube root of 8 squared. These two mean exactly the same thing. Question is, which do you want to do first? Do you want to square it first, then take the cube root, or do you want to take the cube root first and then square it? All right. Either way you do this, no matter how you do this, you're going to get the same answer. Now, for me, I'd rather make it a small number than square it. So the cube root of 8 is 2. 2 squared is going to equal to 4. Okay. Let's try another example. Let's say we have 2 to the negative 2. Well, I can write anything as a fraction, right? I can put this over 1. When I put this over 1, so let me say this actually. So, because I made it a fraction, this clearly does not like being on top. So what's going to happen is that this is now going to be on the bottom instead. But now look at what happens to the negative exponent. It becomes positive. So since there's nothing on top, there's always going to have to be a 1 as a placeholder. So this is going to become 1/4. Okie dokie. All right. So that is if we had to evaluate without a calculator. You can certainly put these in the calculator if you guys want to, but you don't have to. All right. Now, what if we were given you know what? Let's say this. Determine if the given table is linear or exponential. So let's say that we're given a table of that looks something like this. Here's my x values, here's my f of x, and let's say it's -1, 0, 1, 2, 3. And then I got 4, I got 7, I got 14, I got 21, I got 35. Okay. So, let's see here. Now, if you notice, this is going from 4 to 7, which is 3. Then 7 to 14 is by 7. And then 14 to 21 is by 7. And then 21 to 35 is by a lot more. So this is not linear. That's for sure, right? If it's linear, if these are all going by 1s, then these should all be the same, right? Going by the same thing. So it should be 3, 3, 3, 3, 3, or 7, 7, 7, 7, 7, okay? So that's how you would know it's linear. So let's take, this must be exponential. Maybe it's going to be neither, right? So let's see if this is exponential. So to find if it's exponential, what we want to do is saying, okay, so I can see that these right here are all multiples of 7. Not this one right here, but maybe it's because of the -1, right? But these are all multiples of 7. So I'm going to start off with the 7 times a to a power. Okay? So let's take 2 of them. So let's say I'm going to go with 7 times a to the 0 power, and that should equal to 7, right? And then let's take a look at, wow, that works out. I'll take it. 7 times a to the 1st power, that's going to give me 14, right? So what I said was that a is going to equal to f of x plus 1 divided by f of x. So f of x plus 1, which was the 14, divided by the 7. So that means a must equal to 2. Okay? So maybe I have 7 times 2 to the x. Okay? Now, you're going to be like, well, wouldn't that just be 14 raised to x? The answer is no, because this order of operation, this would go first before multiplying this. So be careful with that. So let's try this out. Let's try this out. So if I was to do this, would it work for the very first one? Because that was the one that we're kind of curious about, right? Because all these ones are divisible by 7, so maybe that will work. So let's try it out. So let's see if this will work for -1, right? So if I have 7 times 2 raised to the -1 power, that's going to equal to 7 times 1/2. And that is definitely equal to 3.5 and not 4. All right, so that doesn't work, right? So therefore, this is going to be neither linear nor exponential. So this should say or neither. Okay? All right. So now let's talk about solving equations. Let's say, for example, I have 64 raised to the negative x plus 26, and that's equal to 128 to the x. So the question is, how would I solve this equation? The main thing is that I want to try to get the base to be the same. Meaning, I want to try to get 128 and the 64 to both be the same. And you're saying, oh yeah, I can just do 2 times 64 and it'll give me 128. It's not that simple. All right, it's not that simple. So what we should do is saying, okay, what raised to a power would give me 64 and 128? And the answer is this. If I take 2 and raise it to the 6th power, that is going to give me a 64. And 2 to the 7th power is going to give me 128. So notice how now that the base are the same. So let's go ahead and do that. Let's replace the 64 with 2 to the 6. And this is being raised to the negative x plus 26. And then I got this 2 to the 7th being raised to the x. Right? So what do I do with the powers when a power is being raised to a power? I multiply the power. So essentially I'm going to have 2 raised to the negative 6x plus 156, I believe. And that's going to equal to 2 raised to the 7x. Now, since the base are the same, that means the powers must also be the same. So that means I can write this equation of negative 6x plus 156 is equal to 7x. So 156 is equal to 13x. So x is going to equal to 156 divided by 13 is going to give me a 12. And there we go. Now, you might be given a different type of problem to solve, right? You might be given something like this, which you'll get lucky, right? So let's say if it said, hey, e raised to the x squared minus 3 is equal to e raised to the 2x. Well, if you notice that the base is already the same, there's nothing you need to do. You just notice that the base is the same. So what does that tell me? Since the base is the same, that means the so-called powers must be the same. So that means I have x squared minus 3 must equal to 2x, right? So I see a square term and an equal sign. So I got to think of, let me do this really quick. That's way too big. I see a square term and an equal sign. So I'm thinking quadratics. So now I got to bring everything to one side. I can factor. Then I have x is equal to 3 and x is equal to negative 1. But the question is, can I use those? That's the biggest question I have. Can I use that or not? So what does the E graph look like, right? So that's my biggest question. What does the E graph look like? Because I just said that it looks something like this, is that right? So can I use X values that are negative? And the answer is yes, because there's negative. I can't get negative Y values. So if there's anything that will give me a negative Y value, then that's not okay. But I can use negative X values. So yes, I can use all of that. So therefore, I'm in the clear. So therefore, I can say that x is equal to -1 and 3. And there we go. And that would be my answer. And that would be my answer. There we go. All right. Any other examples that I want to hit before we call it a day? Gotcha. Next thing we want to talk about is graphs. And, well, with graphs, it's going to be talking about transformations. So with graphs and transformations, you guys are going to be doing the same thing with it, right? So we're going to have a raised to the bx minus c plus d, all right? So make sure that you guys, when you're doing these transformations, that we use some key points. Because you guys already know that anything inside the parentheses is going to be backwards, right? And of course, anything that's in front here is going to affect the so-called, actually, you know what? Let's call that, I don't know what to call it. I don't want to call it A, because A is already being used. I can't call it a C, really. I guess I could. Let's do this. Let's call it, because the C was originally there already. So BD plus E. Let's say that, okay? So if that's the case, so the C here, which is the coefficient of A, is going to affect the Y value because it's outside the parentheses. The E is going to affect the Y value, right? Anything inside, don't forget, it's going to be backwards, right? Even the order operation is going to be backwards, all right? So when you are doing those movements, make sure you guys are using some key points and moving those key points. And you're like, what key points? Well, number one is the horizontal asymptote. The horizontal asymptote of an exponential function is y is equal to 0. So you can move that, right? If it tells you to move it up and down, don't get me wrong. If you're moving it left and right, it's going to look the same, right? But if you're moving up and down, then you're going to see it, all right? What other key points? Well, the point 0, 1. The point 0, 1 is always in the original one because anything raised to the 0 power is 1. And then you have the 1 comma a, and you also have the -1 comma 1 over a. Okay? So those are some key points that you might want to move. So let's say, for example, we're given, it says use y equals 6 to the x and find y is equal to -6 raised to x plus 1 minus 2. Okay, so let's take a look at what this is going to be interesting. Let's just do this. So let's take a look at what this graph looks like, right? So let's go ahead and do that. Let me put this in blue, okay? So that blue graph, so when x is 0, y is going to be 1, right? Because 6 to the 0 power. Actually, you know what? Let's do it as this too, just so that we have a table. So -1, 0, and 1. At -1 is going to be 1/6. At 0 is going to be 1, and at 1 is going to be 6. So 1/6 is going to be like right there, something like that, right? And then at 1 is going to be 6, 2, 4. There it is, okay? And don't forget, I do have a horizontal asymptote, right? of y equals 0 right there. Right? So this graph, let me see if I can draw this decent. Oh boy. This is hard to hard to do. I might have to do it this way. More. Oh boy. It's still really hard to do. Looks okay. And this is going to go further that way. And further that way. There we go. It looks kind of nice right there. a little sketchy because that looks like is like oop, and straight out that way. So it's gonna keep on going closer and closer to the horizontal asymptote, but it's not gonna ever cross it here. In the other ones, the horizontal asymptote can be crossed. So when I talk about critical points, so what is this telling me to do? So the first thing it's telling me to do, I'm going to go ahead and highlight it in red. So the first thing is this right here, right? Because there's really a parentheses right here. So we're going to deal with that first, right? When we're inside the parentheses, everything is backwards. So what is the parentheses telling me to do? It's telling me to shift left 1 unit. Okay, so when that's the case, now I said key points. So when I shift left and right, the horizontal asymptote still looks the same. So what happens when I take 0? Actually, let me do it this way. Let me actually put down some points here. -1, 1/6, 0, 1, and 1, 6. And we're shifting left, so we're actually subtracting 1 from the so-called x value, right? So we're going to subtract 1 from the x value. So my new points now are going to be -2, -1/6, -1, 1, and 0, 6. So this is going to shift 1 to the left, so just like that. All right. So that, if you notice, the point is 0, 6, -1, 1, and then this should be 1, 6. Okay. All right. So that is my shift to the left 1. All right. And I guess I probably should take this and duplicate it and make that red and then plot that on there. Okay. So there's my shift 1. Now that I have that part done, when I come out, do I subtract 2 first or negate? Let's go purple. Yeah, I do negate next. Okay. So is that affecting the x or the y? It's affecting the y. Okay. So if that's the case, then I should have multiplying by -1. Wow. So now I'm going to have -2, -1/6, -1, -1, and 0, -6. So now it means that this red curve is going to flip over And of course, my horizontal asymptote is still there. It's not flipping, right? It's still staying there along the x-axis. So now everything here is flipped over. Oh boy, how am I gonna? Oh, I got it. Let's first change the color, and then I'm gonna flip this over. Say. Okay, so there's my new thing here. So there we go. So that's now my purple line, okay? So what happens after that? Now we deal with the -2. Actually, let's do something lighter than that. The -2. So that's affecting the y value, so I'm now going to subtract 2 from the y value. So what I'm going to have left is -2 comma -2 1/6. I'm going to have -1 and -3, and I'll have 0 and -8. Okay, so that is just having me shifting down 2. So let's take my graph right here. Oh boy, there's that right there. Okay, so I should be able to do that. And so I'm shifting down 8. Is that right? Actually, let me. Okay, let's do it this way. Oh boy, because now I do want my horizontal asymptote because that's actually going to move. So let's do this. Let's include this part. Let's include this part, right? And let's. Ooh, I don't want to duplicate it though. How do I want to do this? I have to duplicate it. Okay, let's just duplicate it for now. So I'm here, I'm shifting in 1, 2, 3, 4, 5. Oops, I'm only doing 2. Right there, okay? So notice I didn't want anything else to change, okay? So, with that being said, now this is my horizontal asymptote is no longer there. This right here is now going to be that. So essentially, that is going to be what my end result is going to look like, okay? Where everything is shifted down to. Now, you can confirm by seeing if it connects with 0, -8. 0, 1, 2, 3, 4, 5, 6, 7, 8. It actually does connect at 0, 8, right? -1, -3. It actually does connect at 0, -1, -3, right? Now, this is a little bit harder to connect to see if you got that. We're not really sure, okay? So, but here's my other issue, right? I got to make sure that, let's do this. Let's shrink this a little bit. Let's select this and bring it down just enough so that this doesn't really hinder anything. And of course, I need this as well to be right there, okay? So this way, the horizontal asymptote is going to keep me kind of honest, right? And again, I'm using those key points, and when I'm shifting up or down, I'm bringing the horizontal asymptote with me, all right? Well, I hope that helps. If there's any questions, please let me know. See ya. Bye.